Hello friends, welcome to the new video of Ubuntu series. Last video we saw how to do the package management and its configurations on Ubuntu server. This video we are going to see how to do the network management and its configurations on a Ubuntu server. So network commands which we are going to see are the same what we have on Linux or Red Hat flavors. So we are going to see them, but there are some configurations file which are different on Ubuntu than a Linux server. So we are going to see that too. I have powered on my Ubuntu 02 machine here, and I have attached two more adapters to this server. If you see adapter 3 and adapter 4, I have enabled them and made them host only adapter. And I have powered on my machine already, and I have logged into the server with putty switched into the root. So let's start. So the first command which we are going to see is ifconfig, which we actually already saw when we were doing the network configuration. So this is the very basic startup command for the network. So there are a few things which I'd like to highlight here, what we can look for. So if you see here, it is showing you the IP address for the server. It is showing you the MAC address, which is also called the hardware address, the broadcast address for the server, and the net mask, which we configured, right? And then it is showing you if the link or the network card is up and it is communicating and giving you the information for the network. And if you see this RX and TX, which essentially means received packets and the transmitted packets, and if you see here, it is showing you the packets, and if you see next to it, it is not saying any numbers, rather it is having zero in errors dropped, right? So most of the times, even on enterprise, you should see errors and dropped as zero. If it is not zero or if it is a very high number, that means that your network on the server is actually fluctuating and you have to look for the issues on the network side on the server or probably on the network devices, right? So that is what it means. And if you look the last line where it says RX bytes and TX bytes and some size of the bytes, so that tells that the packets are being transferred or received from this particular network card, right? That's what it tells. Coming to the name, if you see here, it says ENP0S3. A few years back, when we used to do Linux or Unix, it used to be Eth0, Eth1, Eth2. So now that has changed to a standard format, which everyone is kind of agreed on, like Ubuntu, Unix, Linux, everyone has been using the same standard. So if you see here, it tells you ENP, that means Ethernet Network Port for PCI card, and it is at a slot 3. So that's what it exactly means. So on some of the servers on enterprise, you would see is it's as ENO, not ENP. So that tells the onboard device. It is an onboard adapter or onboard Ethernet card which is configured on the server, right? So that is kind of just a standard which has been rolled out on the Unix environment. And this is common, like this is a loopback address, so that's written over there itself. Okay, so the other command of config is ifconfig-a. So what is the difference between ifconfig and ifconfig-a? The difference is, if you see here, it was showing you only two network cards, right? And if you see here, it is showing you two more network cards, which I told you that I have added to the server for the demonstration, right? So, but if you see, it is not showing you any IP addresses, it is not showing you that it is up, there is no RX bytes, there is no TX bytes. That means this network card is configured on the server, but it is not configured to connect to any of the internets, right? So there is no transmission being happening on that on these network cards, right? So that's what it tells. So if config shows only uh, uh, the network cards which has been configured and they are communicating, and if config-a tells you all the Ethernet cards that are configured on the server, irrespective of they are on or they are not on, right? I mean, if there is communication happening on those network cards or not, correct? So that is if config a. Okay. So if you want, you can look for a specific interface too, rather than getting the output for all the interfaces. So if you want to do that, you can just give the interface name with the ifconfig. It will just show you that interface, not all the interfaces. Another command of ifconfig which I want to show here is ifconfig -s, and if we do enp0s9, it is showing you no packets. And if we do an enp0s8, which is our uh, host only network adapter, and if you see here, it is showing you the stats of the network. So if you just want to look for the stats of network on a particular interface when you're troubleshooting, you can do ifconfig -s and the interface name, right? So that's the command. Now, ifconfig can be used to add the interface configurations too. So let's see how can we do that. So we will give ifconfig, and let's use one of the interfaces which I just added, which are empty, not configured yet, and let's give a IP to them, IP to that interface. Okay, let me use 12 IP, and then we can just hit enter, and let's see what we are seeing it here now. If you see here, it is showing you up, and it is showing you a INET address. That means this IP is configured for ENP0S9. Now let's try to log in with this IP on our server. Let's see if we are able to log in. Right, so it is giving me a prompt with that IP. That means our network adapter is configured now, and that is a host only network adapter. So that's why we are able to log in with putty from that IP too, right? You can configure the network for any interface with the ifconfig command itself. You can add on netmask, you can add on gateway and everything on the command itself to configure the interface. But the configuration done with the ifconfig command is not permanent, like I used last time when we were doing the network configuration for host only network adapter. We used the file cat etc network interfaces interfaces file, right? And this file, if you see here, it shows you the interface details, like what is the interface name and what type it is. Actually, let's see the file which we configured for our network interface. So we configured that in the drop directory file, not directly here. So let's see there. So either you can add the interfaces configuration directly into the etc network interfaces file, or you can create a file with the configuration like we did in the .t directory. So let's see the content of this, what we had. Okay, so if you see here, you have the auto which tells that this interface has to come up when the server is booting. Okay, and then it is the interface name, and it is a static interface, not DHCP. It This is the IP address for the interface, this is the net mask for the interface. This file you can define other parameters too, like if you want to give the gateway, you can provide the gateway here, just give gateway and then you provide the gateway IP address. You can provide the DNS also here, so you can provide the DNS and the name server. So this file can contain all those information too, right here. So this is the files where you would configure the network to be permanent. Okay, so next command which we are going to see is if up and the interface name. So let's use the interface which we are using for our NAT interface. So let's see what was that. So this is our NAT interface, right? So before I see if down or if up, let's try to ping Google, and you would see that we are able to ping it, right? And let's bring down our network, NAT network, which we have configured with the interface ENP0S3. So let's bring it down and give if down and the interface name. So it is going to bring down that particular interface. And if you try to ping Google now? Are we able to ping it? No, because that was our NAT interface, which is talking to the outside network through our laptop interface, right? I mean the physical interface. So when we brought the NAT interface down, it is not able to reach to the outside network. So the reverse of this is if up and bring up the interface. And if we try to ping Google again, we should be able to ping it. So right, so that's how, if you want to bring a specific interface for testing or for troubleshooting up or down quickly, you can do that. It is pretty simple, commonly used command. Okay. There is something on the ping which I commonly use, which is not for the network configurations or specific to Ubuntu, but I I want to show it here. So the command which I want to show is ping hyphen I and the interval like 6, suppose, and then let's give google.com. So what's the difference? So when we were doing earlier, by this time it would have shown us 3 times. So the default interval for the ping is uh, 2 seconds. So if you want to change that interval, and if suppose if you are in a maintenance and you know that the server is gonna come up after almost 5 minutes or so, but still you want to keep pinging it, probably you can ping it for after 30 seconds, every 30 seconds, right? So you can give the interval as 30 and then ping it, rather than having a default interval of 2 seconds and every 2 seconds it is pinging, right? The other command which I very commonly use is ping hyphen c and the count. So again, if we go by the Google itself, so what it did, it simply pinged google.com for once and then displayed the output that packet was transmitted or not. I mean, if it was received or failed. So it is saying 0% packet loss. So where is this used? If you quickly want to check that if the server is up or not, that is how you can do it. Otherwise, if you give it without count, it keeps pinging the server or the IP whatever you give. So if you want to filter it in a script, you can do this by having the count, right? And check if the server is up or it is down quickly. So the next command which we are going to see is similar to ifconfig command, which is IP. So if we give IP-a address, it shows you the similar output what we get from the ifconfig. Like if you see the network address, it's if it is up or not, and then all the information which we get with the ifconfig. And if you want to use a shorter form of this, you can give ip link show, which shows you the link information that it is up or not. I mean, if you just want to look at the link status, that is all you get here. So you can use ip link show. Another command which we can use from ip is ip-s, and if you give it the link, it shows you the stats what we were getting with the ifconfig when we are looking at the stats. So here also for every interface it is showing you the rx packets and the tx packets. So these are a few commands which are commonly used with the ip command. So the next command which we are going to see is LSHW, which stands for list hardware, and we are going to run with the class network. So this command can be used to display all the physical devices details. So but we are in the network video, so I am running it with the class network. So if you see here, it is displaying all the information of the physical device, that is the physical network, a network card, like its vendor and its speed and everything. But the information which generally is used, or I have been using more often from this command, is this, the driver and the driver version. So when you do the patching of the firmware on any of the physical servers, this is where you can verify that what driver version for the interface card is, or what version of the interface is, right? So all that information you can get from here on this LSHW command. A similar command with similar output is ethtool, which is another command which is commonly used in enterprise is ethtool. And if you want to give it with hyphen I option and the interface name for which you want to check the details, if you give something like this 0s8, it is going to show you the details, the driver versions, what we are seeing there, the same information here too in quick format. Ethtool command, if you give without hyphen I, it shows a lot of details which is commonly needed. So if you run this command, it is showing you what is kind of the mode for the link, what if it is enabled or not, or what is the speed of the link. So this information, link detected, is which is commonly used, right? So if you have an interface which is connected or not and you want to identify if it is not, you can use a tool. So if we run the same command with our s10 which we have not configured yet, you would see that link detected is no, right? Here it says link detected as yes. So that means the network device, the physical device exists, but it is not having a link connected to it. It is not configured for any transmission of packets, right? So that's what you can use. Eth has a lot of option. I'm not going to go with a lot of the options, but if you want to see all the options, you can simply use eth-h to get the help, and it has a lot of options which you can uh, go through, right? Okay, so next concept what we are going to see in networking is routing. So the first command in routing, the basic one is route hyphen n, which tells the gateway and the net mask and the interface. That means which interface is communicating with which gateway. All that routing information can be seen from route-n command. So if you see here, the default gateway for interface ENP0S3, which is our NAT network, is 10.0.2.2, right? Because we are using the NAT IP. And if you see for the ENP0S8, there is no gateway because it is a host only network. So host only network is like two machines are connected with the LAN card together. That means they don't have to jump to another device, network device, to communicate to each other. They are directly connected and they are directly communicating to each other, right? Another command through which we can see the IP routing information is IP route show. So if we do this, this also tells you that okay, this interface is going through this network, and this is the IP for this info for this interface, and this is the IP for this interface. So a little sort information, and this is the default gateway, right? So this also tells you the route information. Now we need a command trace route, which is pretty common to trace the routes when you are troubleshooting, but by default trace route does not get installed on Ubuntu, so we will be installing the trace route here. So let me do apt install trace route. Okay, so trace route is installed now. Now, if you try to see the trace route for IP of Ubuntu 3 machine, which is uh, 56.18, and let's do the trace route. It, it it does not say any hop. It is just one hop, and it can reach to that server. So that's what I was saying, that there is no network device in between the host only network servers. So this machine Ubuntu 02 is connected directly with the Ubuntu 03. So that is how traceroute can confirm that. But if we do the traceroute for external sites, suppose we take google.com, let's see what it tells you. So you are seeing a IP 64.233.177.113, which is kind of a IP like a load balancer IP or proxy at the Google side, which is yeah, given to the uh, external public, right? To reach google.com, and then after you see that it is showing a hop for the gateway, That means it is going through our NAT interface and it is going through this default gateway, and after that it is not able to reach to the next device, right? So that's what traceroute does. But if you are on a enterprise network linked in together, you will see all the devices to reach to the other server. So you may see 4 hops, 5 hops, like LAN network, internal switch, and then after that your router, and then your proxy server, or any of the network devices, right? So all those hops will come here in the traceroute output. So this command is very commonly used in tracing the route for any of the server or the IP, right? Now, in the troubleshooting, there is another command which is used in very common is ping hyphen I. If you want to test that which interface is being used to communicate to a particular site or a particular server, you can use this command as like this. So ping hyphen I and the interface name, and let's try to do google.com. So let's see what it does. Is it able to ping? No. So why? Because ENP0S8 is not the interface, which is a NAT interface, right? So it is not communicating to outside network. But if we do this with the S3, which is our NAT interface, we are able to ping it. So if you want to quickly check which interface is actually working with which server or which site, you can check through this, right? And if you do just reverse of this, like if you do enp0s8 and then you give the IP of Ubuntu 03 machine, it will ping from S8 but not S3. So if you see here, it is pinging from S8, but if you do this S3, it is not going to ping, right? So that is how you can verify from the ping command that what interface is talking on what network. Okay. Now let's see the route command to delete or add the network configurations. Again, we can do that from the route command, but that is not a permanent configuration. We have to do the routing configurations in the configuration files like etc network interfaces here. So like I was saying, the configuration file is something which is going to be changed on the Ubuntu from Linux. So in Linux, you generally see everything in etc sysconfig network and the interface files, or etc sysconfig network file where you define the gateway and everything. But here it is like etc network interfaces, right? So that configuration file is changed. Otherwise, all these commands is gonna work the same way on Red Hat or the Linux platform too. Okay, coming back to the route. So let's see how to delete routing first. So we were able to ping with the ENP0S3, right? So let's delete the default route. So the default gateway we had was 10.0.2.2, right? That's right, right? 10.0, yeah, 2.2. Okay, so let's delete this gateway for ENP0S3 and let's see what it does. Okay, routing is deleted. Now let's try to ping Google. Uh, we'll simply ping it, not with the interface, but just ping. So it says unknown host. Why? Because the gateway which was providing it the information about google.com and which was working uh, as a door to connect to the outside network, it's broken because the gateway is deleted, right? So that's how you use route command to delete a gateway. And if you do route hyphen n right now, let's see what it shows you. That network interface gateway is gone and the default gateway, it is gone, right? So let's reconfigure it by using route add command and add. Okay, so if you do ping now, it's pinging. So that's how you do the route add or route delete. And if the default gateway is not defined properly, you're not going to be able to reach the network, right? So in route, most of the times these are the generic commands you are gonna need. So I'll leave routing with that. Now let's move on to the next concept which we want to see is bonding. So let's go back to ifconfig. So if we see ifconfig, we have S3 and S8 configured here, right? And if we do ifconfig -a, we have our S9 and S10 configured here, right? Which are the interfaces which we added, right? So now let's see the bonding. So why do we need bonding? So bonding has multiple modes. So we want to club two or more interfaces to work uh, as a bonded interface. Like if they are active passive, if one goes down, you can bring up the other by default, I mean by the configuration. And if it is bonded together to work as one single NIC, it is probably going to give you the more throughput speed. So those are the most common used modes. Like if you say in technical terms, it is active passive mode, or it is a LSAP aggregation mode, right? So those are the two modes which is commonly used in enterprise. So what we are going to see here is active passive right now. LSAP I'm not probably going to show because that needs some configurations on the switch side too. So we have two networks. Network cards and then those two network cards goes to two switches where we configured LSAP, and then the throughput gets increased, right? So let's see the active passive bonding. So uh, let's move on to our path cd atc network interfaces .d. Okay, so let's see here, and I have already created the files for the network bonding and kept them on this path for user one, so that we don't waste time writing it. So let me just copy these to the interfaces .d path. Okay, okay, so now it's copied, and now let's see the content of all these three files what I have written there. So if you see here, it has the interface name like it was having for ENP0 asset, telling it to bring up the interface when server boots up. But the parameters which we want to see here is bond master and bond primary. So this bond master tells that this interface is part of bond 0, okay? And bond primary tells that this interface is a primary interface on an active passive bonding mode, right? And if we see this for S10, it does not have bond primary written there, right? So it is a slave interface. So whenever the bonding comes up, this would be an interface which would be communicating. Unless it gets failed, bond 10 or ENP0S10 is not going to be in use, okay? Now if we do see the bond 0 config file, it has information name as bond 0, which we are giving here, right? So this tells that okay, this is part of this bond 0. And after that, if you see, we have again given the static, and if you see for the interfaces, we have given it manual here, right? But on the bonding, we have given a static like we would give when we are directly configuring our interface. Now we have given the address, now we have given the net mask, uh, and then if you see here, you have the bond mode, which is active backup like I have been saying, right? And this is a mi monitor, which is kind of a communication link between the two interfaces. Like it is checking that if the other interface is up or not. So for 100 millisecond it is going to check that if the other interface is up or not, and if it is found down, the ENP0S10 in this case is going to take over ENP0S9, right? So every 100 millisecond it is going to check that. And if you see here, bond slaves are ENP0 S9 and S10s, which is telling it that, okay, you have two interfaces, S9 and S10 as active passive, right? So this is the configuration, which we already did. So now let's try to bring up the interface. So let's do F up, and like we do for the interface, we will just use bond 0. So let's see. what it does. Okay, so if you see, it is saying no slave join bond 0 continuing anyway. Now if you see the if config -a, what it is going to show you, it is saying bond 0 up, but it is not having any of the communication RX or TX packets, right? Why? And why did it give the error? Because bond 0 in itself is not an interface. It is a combined interface of S9 and S10, which are still down and we have not brought them up. So let's bring up the S9 and S10 and see what happens. S10, and now if we see if config -a, what it is going to show. So ENP0S9 is up, ENP0S10 is up, right? And now here if we see here, the TX packets, it has started showing here, right? Earlier it was 0. So that means this bond 0 network started communicating now. Okay, now let's try to connect with this IP address directly. So we have configured it in bonding. So see there, we are able to connect to it, right? And now let's see a file, cat proc net bonding bond 0, which gives you the information about the bond whatever you have configured, right? So if you see here, it says that it is active backup bond. It is having primary slave as ENP0S9, and it is always primary reselect, right? So whenever both interfaces are up, this is going to be in use always, right? And S10, that is a slave, that is also up. That's what it is telling us here. Now let's bring down the primary interface, which is ENP0S9, and let's see what happens. So I brought it down. Now see what it tells here. So it says active backup and this is up, right? And S9 is gone from here. And if we see it in ifconfig, there also you would see that S9 is not up, right? But are we still able to connect it? Yes. So let's restart the session. So you see there, it gives you the prompt. That means it is still able to connect. So that's what the active and passive uh, bonding configuration is. Even though we brought one interface down, it is still communicating with the other interface. It is very common to use active passive or LACP like I told. So on the physical interfaces, when multiple network devices are used, there are times when we need to do the maintenance on those network devices, like we have to upgrade the switch, we have to do something on the router or any of the network device, right? So having these two network connectivity from two different interfaces gives the higher availability for the server, right? So even though the maintenance is being done on one switch, you are still able to connect to the network from the other interface card and other network device, right? So that's why we use bonding. So this is bonding. There is another concept which is known as bridging, um, which I have not seen in Unix environment in use apart from the Solaris on the T series or M series servers earlier, which used to host the virtual LDOMs and zones on it. So there we used to use the bridge network to configure the network interfaces for those LDOMs and zones. On Ubuntu, I haven't seen it, but yes, now when we are going more onto the virtualization on the Unix platform too, like Docker and everything, this bridging network is going to be used. Another place where you will see this bridging very often is ESX itself or the VMware environment itself. So if you go here on any of the switched off machines, and if you see on the network, one of the options you have is here bridged adapter. So even on the ESX or the virtual workstation or the OVM which you work, they can use bridge network. So it would be like your VM machine having a separate IP and it is directly talking to the outside network or the internet, not like what we have right now as NAT configuration. That means it is not having a separate IP, right? So that's bridging, and the last concept which I want to cover on this network is the DNS. So let's see DNS now. So for DNS, the common file in all the flavors is resolve.conf. And if you see here, we have name server and the IP. So here you give the name server IP, and if you have a search domain, that domain. But because we are running standalone machines on a host-only network, we do not have a DNS server running as of now. So we are going to leave that as is. But this is the file where you would have the DNS information given, right? Another file which works like a DNS is etc host. So let's see how does that work. So if we see the etc host content as of now, it has these entries, right? So it is telling this loopback address as localhost and this name as Ubuntu 02. So if you give localhost, it is going to connect to the same server or same loopback address, right? So that's what it tells. But if we want to tell this that a server, let's suppose our Ubuntu 03 machine and the IP was 18, right? If I want to tell this server that my Ubuntu 03 machine is having this IP, and if I give this and if I run a ping over it, it is going to know that there is a Ubuntu 03 machine, right? See, it is pinging. So it knows that Ubuntu 03 exists and this is the IP for that server. So etc host works like a local defined DNS, not as a DNS server. So this is very common in use concept for the rack clusters or the database clusters where they have multiple servers which needs to interconnect to check the connectivity between each other, and they have a different name for that, and that name has to be known only on those four servers, not to the outside network. So they define that name and the IP on the etc host so that those servers know each other by that name also, right? So that is where it is used. And if you want to give, you can give the alias too. So if I want to give just you just UV3, I can do that too. And if I want to ping by that alias, you can ping it, right? So that's how the etc hosts work, right? Another file which is not part of directly to the network, but does define that where to look for. So if you look at cat etc switch.conf, here it would have something like this: hosts and files and DNS. So if there is an entry in etc host, it is going to look for that first, and it is not going to even search in the DNS if it files an entry over there. But if it is not finding an entry in the etc host, it is going to search for the DNS. So if you want to reverse it or if you want to change it, you can do that in the etc nswitch.conf. So this is how a name gets resolved on the server. So this was all I wanted to cover on this video. There are other network admin commands like netcat, nc, tcpdump, telnet, netstat, mtr in Ubuntu, or even the firewalls like Ubuntu firewalls or IP tables, right? So uh, those commands are I'm not going to cover on this video, otherwise it will be a very long video. Probably I'll try to make another video for just for the troubleshooting and using those commands. So that was all for this video. Thank you. Thank you for watching.